By the end of this video, you are going to build a fully automated Python log analyzer and deployment pipeline from scratch. We will achieve this using Claude Opus. Developed by Anthropic, Opus is an advanced reasoning model engineered specifically for complex logical tasks, architectural design, and deep software engineering. You do not need a complex local environment to execute this workflow. You only need a basic code editor and a sample server log file on your machine. Opus applies production-level logic to these files, providing a path to advanced workflows for anyone, regardless of their background in DevOps. Step 1 is establishing the foundation. Before asking for any code, we must load our raw business rules and sample server logs directly into the model. This diagram illustrates how these two massive blocks of information, your raw logs and business rules, slide directly into a central memory container called the context window. It dictates the massive volume of information the model holds in its active memory during a single conversation. Instructive. Inside the Claude chat interface, click the attachment icon and upload your large text documents directly into the prompt bar. Feeding Opus exact source data, rather than briefly summarizing the logs yourself, eliminates ambiguity. The model now has an absolute, verifiable grounding for the specific task at hand. Opus now functions as a collaborator that references your actual documentation for every response it generates. Now we write a precise prompt. Instruct Opus to act as a senior backend engineer and ask it to extract and summarize the specific error codes found in the attached logs. When we hit enter, watch how the model responds. Before writing a single line of Python, Opus provides a structured, human-readable explanation of the architectural choices it plans to make based on your files. Looking at this interface mockup, we see exactly how the model breaks down the task. On the right, the newly generated Python script utilizes specific extraction logic tailored exactly to the log format we uploaded earlier. Copy this generated script and paste it directly into your local code editor, like VS Code. Opus did not pull a generic template from the internet. It architected a logical, multi-step programming solution based entirely on your raw, unstructured data. Large language models can still hallucinate or fail to account for edge cases. If our production server outputs an empty log file, this newly written script will likely crash. We solve this by utilizing Anthropic's constitutional AI training, which allows the model to critique its own responses. We'll prompt Opus to review the code it just wrote and rewrite it to handle unforeseen constraints. Type a new prompt asking the model to optimize the current script for a large, fault-tolerant enterprise workflow, specifically accounting for missing or corrupted files. This flowchart tracks Opus's structural rewrite. Rather than a localized patch, Opus evaluates the entire application and builds a new, distinct logical branch dedicated to error handling. Here, it inserts robust try-except blocks, ensuring a corrupted log file triggers a safe exit, avoiding a crash. We required Opus to review its own logic before finalizing the application. By forcing iterative self-correction, the AI acts as its own QA tester, yielding significantly safer and more reliable code. Our application is complete. Now we pivot from local software engineering to infrastructure automation by asking Opus for a deployment strategy. To run this script automatically on a daily schedule, we use a required method called CI/CD, which stands for continuous integration and continuous deployment. Return to Opus and enter a prompt instructing it to generate a GitHub Actions workflow using YAML format, configured to run our Python file every midnight. Looking at our IDE File Explorer, Opus showcases its infrastructure as code capabilities. It outputs the exact configuration required to deploy the project, properly formatted in YAML. To implement this, manually create a hidden folder named .github, add a subfolder named workflows, and paste the generated YAML file inside it. Review your finalized directory structure. You should see your core Python application at the root level and your YAML automation configuration staged safely inside the hidden folder. You have used Opus to build the core application logic and the specific YAML configuration needed to trigger it automatically on a schedule. This terminal screen confirms our success. The automated Python script executes flawlessly, cleanly parsing our system logs. In under 6 minutes, we moved from ingesting raw, unstructured documents to generating a complex application, debugging it, and deploying it with enterprise DevOps automation. Soon, you won't even need to manually paste the code. By connecting Opus to an MCP server, agentic AI systems will have the permission to trigger these automated workflows autonomously. The prompt templates we use today are linked below. Feed Opus your own codebase, attach your logs, and begin orchestrating your own automated work.